For 2 days now with big samples and small samples, so they will be blended together today. And we're going to learn how to run the program today and how to interpret what the program tells us. The program doesn't do exactly what we do by hand. Okay, it's a different kind of setup. So I'll give you the steps and then we'll run through the two programs. So your first step is still going to be to write the pair of hypotheses. After that, you're going to run the program, and then you'll see what goes in. When I put the calculator up, you'll see what goes in each line of the program. But you run the program. So we will not be making a graph here. So we're not going to be comparing like a z-score to a z-score to see if it's in the shaded or the unshaded. What the program is going to give you is called a p-value. So run the program and get the p-value. And what this is it's a probability value. And what you do with the p-value to decide whether you reject the whole or fail to reject the whole, because those are still only two decisions, you compare this p-value to the alpha value that's given in the problem. Keenan. And this is the rule. Mr. makes it less than or equal to or just less than here. If the calculator p-value is less than or equal to the alpha, you will reject the whole. So the other side of the coin, if the p-value is greater than alpha, what are you going to decide? Fail to reject the whole. So you compare and then you make your decision. Make decision. And then your last step is to interpret that decision. You know, is it the claim true, the claim false, neat for neat. So interpret the decision.
Do we know why we say we fail to reject versus deny it?
Nope.
Oh, we don't know why?
Nope. Not that I can explain anyway. Okay. Let's try one of each. Okay. Well, our two tests are called tests. Our two programs today are z-test and t-test. And how are we going to know whether to do each one? First of all, the claim will have a mu in it. On both of them. And then what did you say was going to determine Z or T? Sample size. Greater than or equal to 30, we're going to run the t-test. Under 30, we're going to run the t-test. Tomorrow's going to be the first time where we get away from mean. Okay, so. Can I get rid of that? No. Okay, and I'll look at my example. We'll do one of each. You're going to be able to pick out which is which. Look at the book. Over here. Look at which. But sample can only be a whole number. Sample size.
So I was wondering if you like round up to 30.
No, because it's sample size. You either do a whole sample or you don't have a sample, so it's always going to be a whole number. Okay.
That's like those bad 17 words in the ways we've been.
Have 3.5 children. How can you have half a child? So like, if you have the kid's legs running around, like, it's not gonna work. I'm not Monday. Maybe they do like baby on the way and have one. No.
Okay, here we go.
Most people are pregnant.
Okay, in an advertisement, a pizza shop claims that its mean delivery time, at the mean delivery time is less than 30 minutes. You're going to take a sample of 36 deliveries. And you find that the mean here was 28.5 minutes. With a standard deviation of 3.5 minutes. Test at alpha equals 0.01. And we're going to do program. Okay, first step, you still have to write the hypotheses. This is what I would expect on the test. Again, mean delivery time. Get the symbol right. Less than 30 minutes. Making the claim. The ha. The ho is greater than or equal to. Oh, okay. All right. Now we get to run a program. Which program are you going to run here? YZ test? Greater than 30 with the mean and the claim. So we're going to run the Z test. Go on a test, you just tell me the program. Well, on the test you have to tell me what you're putting in too. But on the homework you don't have to. So let's see, for the people at home. Go under stats. Same place we were before, over to test. When we were doing our intervals, now we're going to be using all of these top programs here. The only one we're not going to use are the 2SAMP ones. That's the next chapter. So Z-test is number 1. And we have the statistics. What do you think mu0 means?
What are our predictions, right?
What the claim is. It's the whole. It's the mu of the whole. So what's in the whole? Because we're testing the whole. That's what the 0 is standing for, is the whole. What was it? 30? 30 minutes. Well, the greater than or equal to, or whatever it is. Okay? That's a sigma. Do I have a sigma? No. What's the best, closest thing I got to that? The sample standard deviation, the F. So we have to put the F there. What was the sample standard deviation? 3.5? X bar, the 28.5, that's the sample mean. So it's all about symbols. N, 36. Okay. Forget about the little mu zeros that are here. What 3 signs do you see here? Not equal, less than, and greater than. They're all in what family? The Ha family. Oh, like Mulan, Ha family. Which one did we have in the Ha? The less than. So we're going to highlight the middle one here. So you're going to pick the Ha sign. So just forget about that mu 0 that's there. The Ha. Now you go down to calculate. It's quick. The only thing we want on this screen is this p-value in the middle, the probability. So all you're gonna write down after that is the P equals .005. Huh? You did something wrong. You can run back through it if you want and check. Okay, now we're ready to make our decision. What did I tell you to do to make your decision? Compare it back to the alpha. How does this p-value compare back to the alpha? Smaller. What did I tell you to do if it was smaller? Reject the hope. So we're not looking at graphs or anything, it's just comparing this back to alpha. So in this, and I'll write it down, because p is less than or equal to alpha, we're going to reject the hope. Yep, less than or equal to reject. You don't think you'll ever find one that comes out equal. And now you got to use the poster. What decision do we make? Claim is true. So on a test, the only extra thing you would be doing is telling me those 5 things that we typed into the calculator. All right. Okay, let's go back. Not on test because their numbers should still be there. Here was 30. Standard deviation was 3.5. Sample mean was 28.5. That's where you missed it. 8.5. Sample size was 36. Aha! Okay, one more. Okay, the AAA Association claims that the mean nightly lodging rate, they claim that the mean nightly lodging rate for a family of 4 on vacation in California is at least $134. A random sample of 6 such families. And they have a mean rate of $126. Standard deviation, $12. Test this at 5%. And we're using the program. Okay, so we rewrite. Oh yeah, it does. Assume population normally distributed. Okay, claim is that the mean is at least $134, greater than or equal to, which makes that the whole. Less than 134 will be the hot. Now t-test.